Good morning, everyone. Today's I want to introduce the today's resource person, Nagarajan G. Nagarajan G is postgraduated as power electronics engineer from Anna University, Chennai. Currently designated as a senior application engineer in VI Solutions, Bangalore, and handling the major responsibility of supporting various industries in implementing several turnkey systems and system integration projects using NI products. He is also handling the major responsibility of improving the quality of engineering and science education and eradicating the impoverished methods of education and inculcating the interest for LabVIEW. Nagarajan, as a certified LabVIEW developer, has traveled far and wide throughout India and has delivered throughout thought-provoking lectures which inspire the students and kindle their interest towards LabVIEW, and also visited more than 150 engineering institutions. He has conducted many hands-on training to engineering faculties and students of various branches on LabVIEW basics and data acquisition. He also had conducted many faculty development workshops on various trending technologies, including industrial Internet of Things, embedded and control design, image processing, biomedical instrumentation, etc. He has delivered 85 plus lectures on experiential engineering education on varied technology topics. His key interest areas are measurement and automation, biomedical instrumentation, sensors, data acquisition and signal conditioning, FPGA based embedded system design, power electronics, to name a few. With this short introduction, I would like to welcome Nagaraj ji, and I will like to hand over the session to Nagarajan sir.
Thank you, sir. Thank you so much. Thanks for the introduction. Very good morning to everyone. So, I hope you all are doing good during this pandemic situation. Vishwesh, sir, there is only around six people are there. Shall we start the session, sir? Or we can wait for a few more minutes?
We will wait for a few more minutes, sir, and
Okay.
people are actually joining now.
Okay. So, we'll wait for a few more minutes. Like, once you confirm, I'll start the session, sir.
Yes, sir, sure, sir.
Yeah.
Nagarajan sir, I think we shall start now.
Sir. So, good morning, participants. I welcome you all for this online FTP program. The past 3 days, you people were attending this FTP, right? You people are introduced to an embedded system under NI technology. So, I hope the first day you people have learned about LabVIEW tool. So, why we are using LabVIEW tool for application development, fine, and you people have worked on a lot of functions because today FTP is also going to be the continuation, fine. So that's why just I'm just telling you a brief thing what people you have learned, right? So people first they have learned about why you have to choose LabVIEW platform. So why you people have to use LabVIEW and what is the advantage of LabVIEW tool compared to other programming language, fine. And you have learned how the programming language differs from other programming tool which is existing in academics. At the same time, have reduced to a lot of functions and different data types and about different structures which will help us to develop a complete application. Okay, so if you see the FDP is titled on sensor based system design using graphical interface. So we are going to learn how to interface the sensor. Okay, so and then how we are going to develop a real-time application. So whenever you want to develop a real-time application, so we have to rely on two things. Okay, so till now I have not yet shared anything. Let me share my screen right now. So if my screen is visible, kindly drop your comment in the chat box. I hope the screen is visible now. Yes.
Yes, sir.
Yeah.
Visible.
Yes. Thank
Yes,
you.
sir.
And if you have any queries, kindly drop a comment in the chat box. And if there is any issue also, you can just unmute and talk to me. Fine. So I hope the screen is visible right now. So if you see the FDP program, which is titled on sensor interfacing and design, right? So using a graphical programming language, fine. So which means that whenever you want to develop a system or whenever you want to develop a real-time applications, right? So why we go for building a real-time application in order to monitor any system or any application or in order to develop a product, fine. Or if you want to have a condition monitoring of a system, right? Or if you want to control any device or an equipment or a huge machineries, right? So in order to make that system to work automatically, so we'll go for automation. Okay, fine, we'll go for an automation. And if you want to build a system, right, if you want to measure any parameters, okay, so basically a voltage, current, okay, or if you want to measure any physical parameter like temperature, flow, right? So all those things we need sensors. Okay, so we need sensors, and if you have the sensors with you, so we cannot directly measure those information, right? So why? Because we need to have a right equipment with this so that we can connect the sensor with the respective equipment and we can read the information. Now if you see so I hope you people know about the industry revolution. Right now we are in industry 4.0. If you look industry before 1.0, 2.0, 3.0, right? It comes like they started to use mechanical energy, and they started to use electric energy in industry to develop or to do any process. So later automation comes into picture. When automation comes into picture, right, where we are trying to develop the application using some software as well as hardware. So where we started to use a PC or laptops to develop application. So to develop an application, we need a software. Okay, so we need a software. So it depends upon the area of interest or depends upon the domain in which the industry works. They select different software for developing the application. Okay, so in that, if you see, a LabVIEW is also a tool. Okay, so I hope you people know already. I don't want to tell much about LabVIEW software. Who has developed the LabVIEW software, and NI has both hardware as well as software platform, right? So to develop a real-time application, right? So we need a software platform as well as a hardware platform so that we can make a complete product, or we can make develop a complete, or we can build a complete application. Fine. So the first part is what we need a software. So we have chosen LabVIEW as a software to develop the applications. Okay, so why we have chosen LabVIEW software? As LabVIEW is a graphical based programming language, it's not a text based programming tool, so we can easily develop the logics or we can easily implement the concept. Okay, so I'm just sharing a small experience from my side. Okay, it's not for other people. So even I'm also from electrical and electronics background, right? So we study a lot of subjects as we people are professors, I hope you people are the best persons. I can say every semester you will be handling different subjects. You are teaching different. You are teaching different concepts to students, and you're making the people as an engineers, right? So if you see in such a case, so we study like devices and circuit, like machines, okay, and we study about motors, analog devices, digital devices, and we'll go for circuits, fine, and then we'll try to learn about communication, right? So why when we come to the final year to make a project, so each and every domain is going to give us a small information. So with all those concepts only we're going to develop an application. Okay, so when we try to develop an application, and if you want to complete it, so if you want to control or if you want to monitor, we have to rely on some hardware. Okay, when hardware comes into picture, so we can develop an application through microprocessor based applications, or you can go for microcontroller based, or you can go for embedded system based, or you can go for VLSI FPGA based systems. Okay, so in order to do this, so we need a perfect software as well as a perfect hardware platform which will support to develop a real-time application. So in order to do that, so we have chosen LabVIEW as a programming language, and NI has both hardware platform as well as software platform, right? So when we try to develop any real-time applications, instead of simulation, when we try to develop a real-time application, so when we rely on hardware, so if you want to work with a microcontroller or a microprocessor, so you have to learn assembly language programming. Okay, so we'll be using instruction sets, fine. So or if you're going to use any PIC microcontrollers, or if you're going to use Arduino or anything, so we'll be rely on C programming, fine. So the same way when we are trying to develop anything with embedded based application, so we have to learn embedded C. But the mess, and now as today's topic is about FPGA based systems, so if you want to work with any FPGA based systems, right, either you have to develop the logics or the program using VHDL, or else you have to develop the logic using Verilog. Okay, so when we try to do with Verilog, so we need to know about the basic C platform, so that we can develop the application. That is a place where we will face difficulty as a circuit branch people, because we are very far away from the programming language, because completely we are working on circuits and devices. Okay, fine, we'll be relating on electronics part, fine. So that is breakable by using this NI software and hardware. So if you know how to work with LabVIEW software, okay, if you know how to develop an application using LabVIEW tool, the same thing can be used whenever you want to try to develop a real-time system with the help with respect to hardware also. So you people have experience in the past 2 days, you have worked on a hardware called NI MyRio. Okay, so MyRio stands for Rio stands for reconfigurable input and output. Fine. So the main reason why it has got a name called reconfigurable input and output is because of having an inbuilt FPGA inside the Rio hardware. Okay. So if you look on the LabVIEW, a national instrument, NI has different families of hardware which is used for application developments on different domains. Okay, so if you see, we have a hardware called data acquisition hardware, which is mainly meant for a data acquisition purpose. Okay, and you can go for conditioning monitoring also. When you're trying to work with data acquisition hardware, the DAC hardware does not have any processor, or it does not have any memory or ROM, okay, or RAM, fine. So it has only input output circuitries, and it has something, it has some signal conditioning circuits which is inbuilt inside in order to have a data acquisition. But whenever you want to build a real-time system, or whenever you want to build a real-time applications, okay, so we have to rely on hardware, okay, which has an processor, because we have to dump the code inside the processor so that we can build a standalone application. I can underline this word, standalone application. So in order to develop a standalone application, so we have to switch, or we have to move to a hardware which has a processor inbuilt. Okay, and the most important thing, to have to make an application to be standalone, right, even though when the hardware does not have power, okay, even though the hardware does not have power, when the power goes off and when it gets again power, it automatically has to restart, and it has to run the application again on its own. Okay, so we should have a watchdog timer which is going to help us to make restart your system and makes your application to run automatically, fine. We should have RAM or ROM. Okay, and then we should have what, an option like if you have a hard disk where we can just store, or we can use it for data logging purpose. Okay, so if you have all those features only, we can develop a standalone application. In those case, we have to use the Rio family hardwares. Okay, so which is a part of hardware family under National Instrument. Okay, so you people have introduced on NI technology, both software as well as hardware platform, and you have started to use Myrio hardware also to develop application. But we already, you people are aware that NI software, okay, Myrio hardware has both processor as well as it has an FPGA inbuilt. Okay, it has a processor as well as it has an FPGA inbuilt. So why it has even if it has an FPGA as well as processor, okay, we can develop our application using processor. At the same time, we can develop the application using FPGA also. Okay, so why we have to go for FPGA? Okay, so whenever you want to make, okay, whenever you want to develop a critical based applications, right, whenever you want to give prioritize, okay, whenever you want to make prioritization on your application, and if you want to implement parallelism, fine. So I think someone is sending a message. Even if you want to have a parallelism, okay, so where embedded system based applications will not support. Okay, so the main advantage of using FPGA is what we can do parallel processing, we can do parallel programming, and another advantage of using FPGA is what reprogrammable. Okay, so that's why it has got a name called reconfigurable input output. Okay, so when we try to develop any program in PIC microcontroller or a normal microcontrollers, right? So once we develop the code and if we dump it inside, okay, even next in future if we want to do any modification also, we cannot reuse the same microcontroller or the PIC controllers, right? So we have to go for another one. So when we go for such kind of systems like FPGA based systems and all, so we can reconfigure. Okay, you can reconfigure and you can deploy the code. Okay, you can deploy the code on the same existing FPGA, and you can make your application to run, okay, whenever you do any modification, fine. So by having a lot of advantages, so we can develop a code on FPGA also. Okay, so whenever, and we can acquire or a generated data using embedded processor, fine. So but we can generate or acquire only a single sample information whenever you want to acquire multiple samples. Okay, so when we will hear a word called samples. Okay, so as we know, we are in digital world. So whenever we are trying to acquire any signal, okay, any signal which is changing continuously with respect to time, right? So in order to convert that analog signal into digital signal, so we have to go for sampling concept. Okay, we have to go for sampling, right? In those cases, if you want to sample your signal at a higher faster rate, okay, so which means that we can sample up to the clock, okay, present inside the controller. Okay, but when we go for an FPGA based systems, right, as it is completely a field programmable gate array. Okay, so the expansion of FPGA is what field programmable gate array is, where we can develop and you can dump the code. Okay, so on the hardware, where whatever the code we develop, right, it is going to form in terms of a logic gates, array of logic gates, right? So we can acquire or we can generate a signal in terms of nanoseconds also. When we go for an processor, okay, with respect to the clock speed, we can go for till millisecond at the max micro. If you want to acquire or generate any data, okay, in nanosecond speed, so that can be possible by using FPGA hardware here. Okay, fine. So there are n number of advantages are there. Why, the reason we are going for FPGA, that we'll see one by one. Okay, so and today also the session is going to be hands-on, as you people have hardware with you. Okay, so you can develop the code and you can dump it. Okay, dump, and then we can see the result also, right? So now as we start, so we use graphical programming platform. Okay, so for measurement and automation controls, right? So this is used mainly for testing purpose, for conditional monitoring. Okay, we can have a control based application, cyber physical system, IoT based applications here. So LabVIEW supports, okay, so these much number of domains where it will help us to develop or test any application or products. Okay, and when you see the hardware platforms, right, as I told you, we have DAC based family hardware, we have PXI and modular systems. Okay, so and then we have RIU, okay, which is mainly used for custom design applications, fine. And the most advantages where we can have a third party IO connectivity. Clear? So today, so as you people have already worked on a processor, okay, so you know how to connect the RIU hardware. So by using a measurement and automation explorer, we have to first open the NI Max and the RIO hardware, whatever you people have already used. So that can be connected, configured, okay, in two different ways. One is using wired and another one is using wireless mode. Okay, so wireless mode you people will be learning during your next day of IoT session, where you'll be learning how to have a data transfer in wireless mode. Okay, so today also we are going to have a data transfer through wired mode. We can do for wireless mode also. Okay, so we can try to develop the logics either in FPGA as well as or else you can do it on embedded processor. In case if you're going to develop a critical based applications, or if you have a critical based requirements where we can develop a logic for acquisition only in FPGA, and you can go for analysis purpose in your RT. Okay, so there are different ways to develop the program. Fine. So today, as people already worked on communication protocols, you know how to interface the sensor with the RIO hardware, and you people have developed the code. Okay, so on processor. Okay, but we have not introduced it to FPGA. Okay, so today for the today's session, so we will be introduced to the NI LabVIEW FPGA. Okay, and we are going to learn how we can develop, okay, how we can develop the logics under FPGA. Fine. So as I'm in the remote place, so I cannot go for compilation where it takes much time. As you people have the hardware with you people, so I'll try to teach you how to develop the logics. Even I'll develop the logics in my system. So the only thing is the deployment part. So that you people have to try from your side. Okay, so because as I'm from remote side, I'll not have the cloud access to deploy the code. Okay, so you people can deploy the code and you can see the result over there. Fine. So now when you're going to work with this LabVIEW FPGA, right? So the first thing why we'll be using LabVIEW FPGA is what it is: a field programmable gate array technology, where whatever the logics we are going to build, so that is going to be formed in terms of logic gates. Okay, because when you see your FPGA field programmable gate array, with the name itself, it is gate array, which means it's going to have n number of array of gates over there. Okay, so whatever the logics we develop, right, so that is going to be formed in terms of a gate array here. Okay, so when you see this FPGA technologies, right, we have programmable interconnects. Okay, we have programmable interconnects, which is going to help us to form a, which is going to help us on a routing. Okay, and if you see, we have a lot of logic blocks. If you see inside the logic blocks, so we'll be having the logical circuits. Okay, and then we'll be having the sequential circuits. Okay, which will help us to form the logics whatever we develop, and we have IO blocks which will help us for connectivity purpose. Okay, fine. So when we go for field programmable gate array, right, so whenever we implement, okay, whenever we implement any logics, okay, whenever we implement any logics, as it is a graphical based programming language, right, we try to develop the logics in LabVIEW platform. Whenever we try to deploy it, whatever the code we developed, okay, so that is going to be formed in terms of array of gates here. Okay, in the form of array of gates here. Fine. So when you see this, right, so when we form a field programmable gate array, so if you see here, as I told you, the main advantage, okay, the main advantage of using LabVIEW FPGA is what? So when we have a field programmable gate array, so it is going to be what? A silicon chip which has an unconnected logic gates over there. Okay, it has an unconnected logic gates here. So we can define, okay, we can define the functionality of FPGA, right, by using software. Okay, so why we'll be using software? To configure the FPGA gates. Okay, by configuring the FPGA gates here, and we can develop the task in software. So which software we are using here? We are using LabVIEW software to develop the application, and then we are going to compile them. Okay, and then we are going to compile them into a configuration file. Okay, so finally when we try to dump the code, okay, the edge, the end stage, whatever the codes we developed, right, so that will be converted as a big file here. Okay, it is going to convert it as a big file, so which is going to have the information about the gates. Okay, so which we wired together. So when you see here the FPGAs, okay, as I told you, right, the FPGAs are completely reconfigurable. Okay, completely reconfigurable, and it instantly takes on the a new personality. Okay, so the new personality whenever we download a different configuration of circuitry. For example, think that if you see in the screen, right, It's a combination of gates. So they have an OR gate and they have two AND gates here. Think I have developed the code up to this portion, okay, an OR gate and an AND gate. So I've dumped, okay, they dumped the code under FPGA. Later I want to add some features like adding an XOR gate here. So once I develop the logic, okay, once I do a small modification or think, first initially I've developed the code without loop, and the next time I want to add a loop in order to make my program to run continuously. When I add a while loop with an existing system, right? So which means that we have just modified the logic, okay? So when we modify the logic and we try to deploy, so the FPGA will completely it's as it is a reconfigurable, right? So where we can instantly change the personality of, okay, into a different configuration of circuitry here, okay? So that is the most advantage of having FPGA, okay? So and the most important thing is what the FPGAs are mainly used for processing the components, okay? So in low to medium level of electronics, fine. So where the time and cost of the developing and the fabrication of and ASIC, okay, is very easy, fine. So and if you see FPGA benefits, okay, the main advantage of using FPGA hardware are what? As I told you, it is reconfigurable through software, okay, which will make our task to be very flexible, okay, unlike a microprocessor or an ASIC. So what is meant by ASIC? Application specific integrated circuit, which is only meant to do only that application, okay? So when we compare to those, okay, it's going to be very flexible because we can modify the functionality on an FPGA here, okay? And we can mod, and the most another advantage is what? We can also execute a specific task, okay, so in an efficient way by using the FPGAs, okay? And we know the FPGA execution, if you see, the FPGA execution is what? It is controlled, right? Which is controlled by programmable interconnects, okay? So we know it has a programmable interconnects, it has a logical block, and it has an IO block here, fine. So and we can implement a parallelism task, okay? That is the next thing which we are going to see. So we can implement what? Parallel task within a FPGA, so which will execute simultaneously, okay, which will execute simultaneously and independently of one another, okay? So because of having all these advantages, right? And the most another important thing is where operating system is not required, okay? So when you go for an embedded based applications, right, an operating system is required. As you people know, we are using a real-time operating system when we go for embedded based applications where it has a Linux software installed, right? So we'll not go for a general purpose operating system because general purpose operating system is meant for a multitasking application. But when you see this or task is meant to do only the particular task. But when you see here, even that operating system is also not required because we are going to directly implement the logics on the respective hardware, okay? That's why FPGA applications can execute reliably, okay? So these are the benefits of having FPGA based applications, fine. So and one more, the most important thing, if you see here, flexibility, okay? So why? Because we can have a rapid prototyping capabilities, fine. So we can test an idea, okay? So if you want to develop a system, right, we'll not directly develop. First we'll try to verify the concept and we'll try to test, okay? So without going for a fabrication process, right? So we can do, so when we go for an ASIC based design, so once it is fabricated, it cannot be used for other applications. So that is that all these things has been break by having this field programmable gate array techniques, okay? So because we can do the changings, okay, so we can do a lot of changings whenever we try to test. It is like a trial and error. You can develop a system, deploy, test. If you are facing any problem, again you can just open the code, modify, you can develop the logics, and you can again deploy it, okay? So that's why it is giving more flexibility to us to develop an application in a very reliable way, okay? So and if you see about the performance, okay, if you see about the performance of the FPGA based systems, right, so it can go for parallelism, okay? So where you can share, okay, where you can share the field programmable gate array to do a parallel task. But when you go for a real-time operating system, as we know, it is meant to perform only one application where we cannot go for the parallelism based applications, okay? So that is one advantage of having this FPGA, because FPGA exceeds the computing power of DSPs, okay? So how DSP is digital signal processing of processors. So how by breaking the sequence of executions, okay, and it is going to accomplish more clock cycles. Fine. So if you see controlling IOs at the hardware level, okay, so which gives very faster response time, okay, which is going to give a faster response time, and it is going to be specialized functionality to match the requirement, okay. So that's why the performance wise also, where we can go for a true parallelism task, it is going to give us more advantage, okay. And the next thing is about what? Reliability, okay. So the next thing is what? Reliability. So when reliability comes into picture, right, so FPGA is truly a hardware implementation of programming execution, where we are not going to do any processors here, okay. And we don't know, we already know that we don't have an operating system here which minimizes the reliability concern with the true parallel execution, okay. And determinism, okay, that is the next important thing, okay. So determinism hardware, okay, which is dedicated for every task, okay. So every task, so in it is going to be directly in contrast with the processor based systems, okay, because when you go for a processor based system, it often involves several layers of abstractions, okay. So we have to schedule the task, and then we have to share the resources here for multiple processes, okay. So that can be broken by using the FPGA based applications, okay. And if you see here, so when we use the and you see and another one is what? Reconfigurable, okay. So reconfigurable, you can create and alter the existing specified task here, okay. So these are the things which gives you more benefits when we are going to develop, okay, when we are going to develop the FPGA based systems, okay, instead of going for an embedded based applications. Fine. So and the most advantage from my side, you can make use of the same LabVIEW programming to develop the code instead of going for a huge number of lines of writing the code on VHDL or Verilog here. Fine. So and if you see, that's what I told you, right? So you can see in the same slide itself. So to develop a logic, okay, so you can, in order to acquire a signal from an analog signal, you can directly take an analog input IO nodes, and we can use, if you're going to acquire a continuous signal, right, so you have to go for a continuous, you have to take more number of samples. We can create a small memory or a buffer where we'll be acquiring the signal through the analog input, and that will be stored inside the memory, which can be used for later purpose, fine. And then we can complete the application. But when you go for an VHDL programming, so you need to write lines and lines of code here, okay. You need to write lines and lines of code, fine. So to complete the small analog input acquisition application, fine. And if you see the advantage of using LabVIEW software, LabVIEW FPGA system, sorry, not LabVIEW software, LabVIEW FPGA systems, right? So it is used in wide areas of application, okay. It used in wide range of applications here. So if you see, it can be used for an onboard processing, where you can acquire a signal and you can apply inline processing like filtering, okay, right, or data reductions here. And the one more, high speed control, okay, because all the IOs are directly connected to the FPGA pinouts, right? So we can use single point IOs, okay. So with a PID controller, okay, or we can use lot of control algorithms to implement onboard controls, okay, onboard controls with the loop rates in terms of 100 kilohertz, okay. That's what I said, right? We can go up to a millisecond, we can go up to micro or nanosecond speed acquisition. That's why high speed of control here, okay, fine. So if you see, the next one is going to be, you can make use of digital communications, and you can go for protocols, okay. I hope you people have already worked on different serial communication protocol, which is supported by NI MyRio. You have worked on UART protocol, I2C, and the people have already worked on what? Another one, SPI protocols using MyRio, right? Here this also supports, okay, and we can interface with standard, okay, or custom protocols when we go for LabVIEW FPGA, fine. And it offloads CPU processing. We can directly communicate through dynamic memory access. You can see it here, right? So when you see, this is the mode, okay. So scan mode with LabVIEW FPGA. So this is the architecture of Rio architecture. I hope people already knows about the architecture. We have IO modules, and we have FPGA inbuilt, and then we have a real-time processor. And when Rio comes into picture, we have different families of hardware. Excuse me. We have different families of subcategories of Rio hardware, starting from single board Rio that I have kept in another slide. Yeah, you can see here the NI Rio family. Okay, so the first one we have single board Rio. Okay, and the next one we have compact Rio. So my Rio is not included here. So my Rio is mostly meant for academic purpose. These are all the industry hardware, okay, which is used in industry. Okay, so we have compact Rio. So compact Rio is mainly used for application development, which can be implemented in a rugged nature. Okay, so some Rios will be integrated and something will be compact, and you can have PXI based Rio family hardware where you can have develop a real-time application either using processor or FPGA, and you can see in the slide itself where all the IOs, okay, I'll just show it in this one, where all the IOs are directly connected to the FPGA module, right? So whenever you try to develop a code under processor alone, we call this as a scan mode, where FPGA will directly transfer all the data to the IO memory table, okay, and then the processor will access those values, and then it is going to perform the application. But when we try to develop the logic under LabVIEW FPGA, okay, the programming way is going to be slightly, it differs. But if you see here, the programming language which we use, the base platform is going to be LabVIEW only. Fine. So this is the operation, how the compact Rio or my Rio or a single board Rio will work when we try to develop a logic under FPGA or processor here. Okay, and this is the architecture. Okay, so of this Rio hardware, if you see here, we have LabVIEW FPGA, we have LabVIEW real time, and then we have LabVIEW, which is for Windows platform, where we are going to develop the application. Okay, we are going to develop the application on Windows. Okay, because that is a place where we have installed the LabVIEW software, and we are going to develop the logics. Fine. So when you try to develop, okay, when you try to develop the application under LabVIEW FPGA, so we call it as reconfigurable FPGA, right? So that informations can be, okay, so that informations can be transferred, okay, to the processor, okay, to the processor having dynamic memory. See, you can see it is going to communicate through dynamic memory access, and so that the data will be transferred to the embedded processor. Okay, in case if you want to transfer a data to system, okay, if you have a remote system where you want to have a data transfer, right? So where you can go for network streams, or else you can go for a shared variable concept. You'll be learning about the shared variable concepts in the next tomorrow session. Okay, by using those IO nodes or by using the shared variable concepts, right, we can have a data transfer. Okay, this is how the communication will happen between the FPGA, a CPU, and the other systems here. Fine. So this is what I thought of explaining you people, how it is going to communicate with the processor as well as your systems. Fine. So, and if you see here, so as I told you, so we can go, the best thing is what, so we can go for offload processing, and you can develop hardware in loop based systems. Okay, HIL plays a major role where you can simulate, you can ask like what is the use of HIL. So by using hardware in loop, you can simulate a sensor, you can emulate a protocol, and you can implement, okay, important parts of HIL system that are very difficult to implement on the processor. Okay, simple example, whenever you want to test a machine, okay, whenever you want to test a motor, instead of once you manufacture a motor, and if you're going to apply a lot of loads and other parameters to test the motor, so we will be mathematically we are going to develop, okay, and motor model, okay, and then we are going to test it. Okay, that's why it's a hardware in loop. Okay, so what exactly your motor does and what are the parameters you want to apply for the motor for testing, right? So all those things will be completely developed by using NI software and the Rio hardwares. So that's what we call as hardware in loop. Okay, fine. So where it is going to give the signal, okay, and then it is going to test the parameters. Okay, so which makes very cost effective. Fine. So hardware in loop, complexity, timing, and synchronization, offload CPU processing. Okay, these are the different advantages of using LabVIEW FPGA. Fine. So if you see the LabVIEW FPGA, so the components, okay, what are the components of a LabVIEW FPGA system, right? So usually, okay, so FPGA are programmed using what hardware description language, that is called HDL, okay, or as we call it as VHDL or Verilog, right? So when you want to use these tools, right, to develop an application, it requires a high level of understanding, okay, to even compute a simple task, okay, and it becomes a very barrier for many people to implement the FPGA technology, okay. And also this tool is often intuitive for testing, is not intuitive for testing and control, okay, engineers, because FPGA, VHDL and Verilog, it needs much time. But when we know how to work with LabVIEW, and if you know how to work with LabVIEW FPGA, it makes us our task very easiest way, because whenever we want to develop an FPGA systems, right? So the basic component is what we need: LabVIEW FPGA module, we need the Rio drivers, NI Rio drivers, and then we need the Rio devices, okay, and also the Rio targets here. Fine. The LabVIEW FPGA module, it's going to allow LabVIEW, okay, to target FPGA on reconfigurable input output hardware, so that we no need to go for high level programming language, okay, which makes our engineers to take an advantage of, okay, performance and flexibility of FPGA without using the such type of design tools here, okay. So that's why we always prefer, okay, so we can develop the LabVIEW FPGA based applications by using LabVIEW software as well as the N9 hardwares here. Fine. So now I'm going to show a small video, because when I talk about this LabVIEW FPGA based systems, right? So we can talk much, but you can have a practical experience. You can have a practical view why and how NI has used, okay, how NI has used the LabVIEW software to develop critical time based applications. Okay, I have some few videos with me, so where you can watch it and you can experience why Rio is needed, why LabVIEW FPGA is required to develop such kind of applications. Fine. So in order to show the video, I have a small issue with my system, okay. So where if I play the video where you cannot hear the audio information, so I'm going to join through another system, okay. So I want the coordinator to kindly accept accept my request. Maybe you will get this from Nagu METD. So the coordinator, please accept my invitation. So let me join through another system, so where I can show the videos, okay. So where the participants can also hear the information whatever they tell in the video. Sir, could you please accept the invitation, please? Vishwesh sir, can you please accept the invitation so that I can show the videos to the faculty? They'll experience the usage of LabVIEW FPGA. I think the coordinator is available. So I'm waiting for the acceptance through the another system. Uh, or else, Datta Prasad sir, can you hear my voice? Sir, I need someone to accept my invitation from another system so that I can show the video. Vishwesh sir, Vishwesh Kumar sir, can you hear my voice?
Hello, sir.
Yeah, sir, please kindly accept my invitation, sir. I'm trying to join from another system
Okay, sir.
because in my system there is a problem with the audio part. Fine.
Okay,
So
sir.
I
Yes,
want
sir.
to
Yes,
show
sir. Yes,
some
sir.
video to the participants.
Yes, sir. Yes,
So
sir. Yes,
I've
sir.
just sent a request through another system. I use it only for playing the videos.
Okay, sir. Sir, you use the Chrome browser, sir, for
Yeah,
that
I'm
purpose.
using the Chrome browser only, sir.
Actually, I have put auto admit actually, so
Oh,
automatically it will admit. You just try once
no, I
again.
asked. Still, it is asking to join. So you'll join them. someone has to let you in. It is showing it as someone has to let you in. I'm using Chrome
Uh,
only in that system also.
Sir, you close that tab and open another tab and try to
Yeah,
get
I'll do
into.
it again, sir. I
Yes, sir.
just
Yes, sir.
check once. I've given the request asking to join. It is showing actually. So did you got the request?
No, sir. Here I am not getting any pop-up as such, actually. So I should get a pop-up, but I'm not getting the pop-up.
I have sent the request. It is showing us asking to join.
Wait, sir.
Okay, okay, okay. Sir, sorry. I think I have used in another link. Hello. I used an inaugural link. I think so. That's why same thing I did in the morning time also. I'll try to join now, sir.
Nagarajan, sir.
Yes, sir.
Now you try, sir.
Yes, sir. Yeah. No, no, sir. I have used. I think what is that? The previous inaugural link. I think so. Now
Okay, sir.
I'll try to put the link and I'll join, sir.
Yes,
Sorry.
sir.
It's
Yes, sir.
my mistake actually.
Okay, sir. Yes, sir.
I'll join now. Yeah. Just now
Now
I
you
sent
are
a
allowed,
request.
sir.
Yes, sir. Yeah.
Yes, sir.
Thank you,
Yes,
sir.
sir.
Thank you so
Yes,
much.
sir. Yes, sir.
Okay, I think you can hear my voice in another. I'm just joined through another system. This is only for. I'll be using this to show the videos of a real-time system where you people come to know about what is the advantage of using LabVIEW FPGA. Right. So let me share the screen. I'll be using this to show only the information. Before that, I would like to know: have you people have already watched the pencil sorting video, pencil sorting application? At least you people can drop yes or no in the chat box. Have you already watched a pencil sorting application during this FTP program? Any of my colleagues have already shown to you. Participants, please kindly reply. Yes, okay. Next thing, have you seen an application called ball bearing sorting? Ball bearing sorting, sorting of different sizes of ball bearing. Yes or no, you can just drop a comment. Whether you people have watched a ball bearing sorting application. No, okay, thank you, because that is related to completely an FPGA based application. Right, I'll show now. So before this, I'll tell you what exactly this application is about. It's about ball bearing sorting. Okay, so they have actually three different sizes of ball bearing, which is stored in a storage, and it is they are going to leave it on a fly. So when the ball bearing before reaches the floor or the place, okay, so they have developed a system which is going to grab the image, okay, and it is going to calculate the size of the ball bearing on the fly, and then it is going to send the information to the motion controller where they have a pneumatics which will turn or which is going to rotate with respect to the command, and each and every size of the ball bearing will be stored in a separate storage. This entire system has been completely developed by using NI LabVIEW software as well as NI hardware. Okay, so where you can experience how effectively LabVIEW FPGA is going to help us to develop a program. Okay, so kindly watch the video.
Now, one of the primary uses for PACs is in machine automation. And our newest platform, PAC platform, Compact Rio, is ideally suited for these type of applications. So Kyle and Jonathan are going to show us how we're using Compact Rio and our Compact Vision systems to do high-speed machine automation.
Thanks, Tim. An important feature of NI programmable automation controllers, or PACs, is the ability to reconfigure and customize onboard FPGAs with LabVIEW FPGA. This feature is particularly important when automating high-speed machines that require fast and reliable control. In this demonstration, we've taken the Compact Vision system and Compact Rio and built a machine that can sort different size ball bearings on the fly.
Now, guys, when Kyle says on the fly, he means literally on the fly. The machine we have here is loaded with hundreds of different ball bearings that differ in size by just a 16th of an inch. Each ball bearing will travel down a ramp before it drops to the air. As it falls, the Compact Vision system, acquiring images at 100 images per second, will measure the size of each ball bearing to determine whether it is 1/2 inch, 9/16, or 5/8 of an inch in diameter. The Compact Vision system then communicates that result to Compact Rio, which is controlling a high-precision cymatics rotary stage. As the bearing is still falling through the air, the rotary stage will quickly move to the exact position necessary to deflect the bearing into the correct bin. You want to see it work, Tim?
I think I do.
All right.
There we go. All right.
I see the Compact Rio system, I see the Compact Vision system, but where are the motion controllers?
That's a great question, Tim. So we took LabVIEW FPGA and NI Soft Motion and reconfigured the FPGAs on both the Compact Vision system and Compact Rio so they both become motion controllers. So the FPGA on the Compact Vision system is controlling the motor that's dispensing these ball bearings down the ramp. And the FPGA on Compact Rio has been reconfigured to control this rotary stage that's powered by a brushless servo motor. With NI Soft Motion, we can turn any NI PAC into a motion controller. So really, Tim, we don't need specialized motion control hardware for this application. We just need NI PACs.
Why don't we test our two motion controllers out a bit by speeding things up? You guys up for it? Nice. Now, how fast is your machine control going there? Well, as you can see on the screen, guys, we're sorting about 3 bearings a second, but I gotta be honest with you, Tim, this isn't the work of Kyle and I. This entire sorting machine was built by a team of engineering students from Texas A&M University. They learned to program with LabVIEW, LabVIEW Real-Time, and LabVIEw FPGA, NI Soft Motion, and the NI Vision Development Module, and they completed this entire sorting machine in just 6 weeks. Actually, they're here with us today. Guys, come on, stand up. Nate and Scott, take a bow. Texas A&M.
Okay, so you people have seen a small video which tells you about. I have different videos which I'd like to show in different sessions. Okay, we have 2 more sessions left out. Okay, so where you can see how lab FPGA is used, and I have just spoke about something called hardware in loop. Okay, so that you can view now. So where Siemens have the Siemens Wing power generation, they have used the graphical system design platform. Okay, and even in automobile also they have used that. I'll show later. Maybe you can just look on the Siemens wind power.
Today, wind energy is one of the fastest growing sources of clean, renewable energy. The National Instruments graphical system design platform of powerful, flexible interlab software and user-defined hardware is helping the wind industry to tackle difficult technical challenges, including control system design validation, automated component testing, and machine condition monitoring in the field. Graphical system design is the use of a high-level software environment for instrumentation and control that simplifies development to enable higher quality designs. For example, Siemens Wind Power uses LabWind to ensure their wind turbine control software meets the company's exacting standards for quality and reliability.
We have a lot of focus on reliability of our turbines. Our customers are very focused on having the turbine available every time the wind blows, because that's when they make money. We've used LabVIEW to develop the entire software for the test system simulator. The LabVIEW and National Toolchain has really helped us speed up the development time. There's a great integration between hardware and software. That stuff just works. I was raised with C and C++ as such. This is function-based programming, and then moving on to this graphical and there's a flow programming really was new to me and took a change of mindset, but I've come to appreciate it quite a lot. I would definitely recommend others to use graphical programming in their work, because it's an intuitive way of programming.
Siemens Wind Power is just one of the wind energy companies around the world that is using graphical system design tools from NI to improve the world around them.
So this is also a small demo. So where they have used NI technology. Fine. So let me switch to my screen now. Okay, you people can hear my voice here. Fine. So there is a small audio problem in my lab, so I have just switched to another lab, only just to show how really NI has used in different industries for application development. Fine. So here, let me share the screen now. So people can see my screen. Yes. So we'll continue. So we have just stopped. Thank you. Thanks for the reply. Okay. Please, just a moment. I'm hearing some disturbance. I'll just sort it out. Sorry for the interruption. So there was a small disturbance over there. So we were discussing about FPGA. Okay. So this is also a small real-time example. Okay, you can see the FedEx. Okay. So those people are the huge support for cargos, right? So they have used this embedded temperature monitoring and control, okay, of the suppression systems. You can see here the challenge is mainly of prototyping and deploying cost-effective systems, right? So they have used NI Compact Rio, LabVIEW Real Time, LabVIEW FPGA, okay, in order to develop a temperature monitoring, okay, a prototype, okay, so a temperature monitoring, okay, and a control of suppression systems here, okay. So the benefits, right? Rapid embedded prototyping with Compact Rio, and they can deploy it with the NI single board Rio here, okay, fine. So this is also one small example of using LabVIEW FPGA, and you can see here this one, okay. So they have used Compact Rio, LabVIEW for structural health monitoring of 2008 Olympic venue. Fine. So this is also one small example where I can show, where I can tell you people where LabVIEW is used in real-time applications, okay, in different aspects on different industries, okay. So I have few more videos also which I can share with you people, and this is the one which you people have already shown in the video also, okay. See, they have developed a hardware in-loop simulator for wind turbine control, okay, on software testing. So what they'll do is they'll try to test, okay, they'll try to simulate the entire wind power system, right, by using NI technology, and they're going to test the performance of the wind power systems, okay. So you can see they have mentioned it for real-time application test system for hardware in loop, okay. So they are what the challenge, okay. So improving the automated testing of a frequent software release of Siemens, okay. So where whenever they want to update, they want to check whether it is supported by the existing machineries, right? So which they can directly simulate and they can check, okay, for the Siemens wind turbine control system, okay. And you can see here they have used a different hardwares, okay. So different hardwares are LabVIEW FPGA, LabVIEW Real Time, and they have used the PXI and as well as NI hardwares also for this hardware in loop systems, okay. So like this, there are n number of industries are using LabVIEW software, and even you people as an academic people, you will be doing a lot of research works, projects, right? And you can kindle the interest to these students, okay, students, to learn about this FPGA technology, and they can develop a lot of applications. Sure, it will help them for the core placements, okay, fine. So when as you people are from circuit branch, if you want to get a job in core, we should be a master in a tool, okay. So if the students are interested, they can choose this tool, and even as if people are from doing a lot of research works also, and whenever you want to develop any system or prototype or any applications, you can make use of this NI LabVIEW software as well as hardware software here, okay. If you see here, when we go for LabVIEW FPGA, okay, so how the LabVIEW FPGA is going to work, okay. So once we discuss about all these concepts only, we can develop the code, fine. So if you see the LabVIEW FPGA module, what it is going to do, it's going to compile our LabVIEW VIs, okay. It's going to compile our LabVIEW VIs, fine. So and once it compiles the LabVIEW VI to the FPGA hardware, right, so our graphical code, okay, our graphical programming language will be automatically translated at the back end, okay. At the back end, our graphical code is automatically translated to a text-based VHL code, okay. So the text-based VHL code, okay, and then, okay, the Xilinx compiler. So we have to use a compilation tool, okay. So the Xilinx compiler tool, which is going to synthesize your VHDL code, okay, the Verilog code into a hardware circuit, okay, in the hardware circuit of our LabVIEW design, okay. So and then this process also applies timing constraints also to design and tires to map the design to the low level hardware resources on the FPGA, okay. So directly once we develop a code in LabVIEW, it will not directly deploy, okay. There will be a lot of stages will be happened in the intermediate before deploy, okay, after before completion of the deployment process, right. Lot of steps will be taken care, okay, by the compilation toolkit. So where the code will be converted into VHDL after that, okay. So then this will be converted, okay, so into the hardware circuitry, and finally, okay, it is going to be deployed at the end, okay. So the entire thing will be converted into a bit file, okay, whatever the logics we develop, so that will be converted into a bit file, which contains our LabVIEW programming instructions, okay, which will be downloaded to the FPGA target. Okay, that will be downloaded to the FPGA target. So when we run the application in FPGA, okay, so the bit files will be loaded into the FPGA chips. Okay, so once it is loaded, right, and it is used to reconfigure your gate array logics. Okay, for example, as I told you, I have developed a small program without a loop. You have just compiled it, so it has converted into the VHDL, and finally the data, the bit file has been generated, and you have executed the program also. Okay, then next step, whenever you want to implement a small addition logic, or even if you want to implement a wait function, or if you want to include a loop also, and then when you run the code, it will not execute again it will start to compile. Okay, the modified code will be converted to VHDL, and finally it will be implemented in the hardware circuitry. At the end result, we'll get a new bit file. Okay, we'll get a new bit file, so where it has the updated information, and that will be loaded into the FPGA. Okay, so by using the gate array logics. Fine, so we can download the bit files to the non-volatile memory on the FPGA device. Okay, so that the bit files will load instantaneously to the FPGA from the flash memory when the device powered up or reboot. Okay, so that's what I say. Whenever you want to create a standalone system, okay, whenever you want to create a standalone system, right, so we can just download the bit file to the non-volatile memory. Okay, so that whenever the power goes off and the power gets whenever again the Rio gets powered, and when it gets rebooted, okay, and instantly the bit file will get loaded to the FPGA from the flash memory. Okay, so there is no operating system is needed, or it is not present in the FPGA chips here. Okay, because it's completely of hardware. Fine, so this is how the LabVIEW FPGA is going to work. Okay, so we'll see one by one. Okay, so we'll see one by one how we can develop an FPGA based system. Okay, so whenever you want to develop an FPGA based system, the first thing is you should have a LabVIEW software. Okay, and you should have LabVIEW FPGA. Okay, you should have LabVIEW FPGA. So in case if you're going to have a data transfer between the RT as well as FPGA and all, so three things are mandatory: LabVIEW, LabVIEW RT, and LabVIEW FPGA, where we can develop an application. Okay, so once if you want to develop an application, right, we need to configure our systems. Okay, we need to set up and configure our FPGA systems, right? So we need to install the appropriate drivers and the software required for this to develop the FPGA based application, and then we have to install, okay, and we have to use hardware, FPGA based hardware, and we need PC. Okay, next one is what we have to configure our targets. Okay, we have to configure our targets. Okay, each and every target has its own hardware setup and installation instructions, right? For example, if you want to install some embedded based DAC hardware, we need to use DAC driver. Okay, in the same way for Rio hardware, LabVIEW, LabVIEW RT, and LabVIEW FPGA is required. Okay, so when we're going to install, okay, when you're going to install the software, right, so these three softwares are required. Okay, so if you're using only real time, okay, so we can go for LabVIEW. Okay, and then we can go for LabVIEW real time module. So if you're going to use an NI Rio drivers, okay, an NI Rio drivers, and if you're going to develop an FPGA based real time application, right, so then our system should have LabVIEW, okay, a full software, okay, or a professional software. We should have LabVIEW real-time module, and then we should have LabVIEW FPGA module here. Okay, so the LabVIEW FPGA module only compiles the VI to the FPGA hardware. Okay, by using multiple steps over there that we will see one by one later. Fine. So this is the introduction about LabVIEW FPGA. Okay, right? So next step, we are going to learn how to develop the logics under LabVIEW FPGA. If you have any queries, please let me know. Any doubts regarding the introduction to LabVIEW FPGA? Any queries? Any doubts? As we have only 5 minutes for this first presentation of the day. So if you have any queries, please let me know. and make sure that you people have installed the respective drivers in your laptops, okay, so that you people can take a hands on. Okay, so even though if you doesn't have, okay, even though if you does not have Rio hardware also, maybe if people are attending the sessions, okay, so without using hardware, okay, you can try to simulate the hardware. The only thing is we cannot view the output, okay, but we can develop the logics, that is possible. Okay, so please let me know if you have any queries, participants. Yes, sir.
Participants, if you have any specific query, you can post it in the chat box also.
Okay, so if there is no queries, I hope the people have installed the software also in your systems and laptop. Okay, which latest version of LabVIEW you are using? I'm using 2018 version only in my system. So how can I download the software? Okay, it's simple. I can show you. You can just look on the screen. Okay. So for example, if you want to work on NI Rio, My Rio hardware, NI My Rio, okay, software. Okay. So see, you'll get this option NI My Rio software bundle. Select this option. Okay. You'll get another screen. So here you have to select the version, okay, whichever version you have, that you need to select. See, the most important thing is, if I have LabVIEW 2018 in my system, I want my drivers, okay, the LabVIEW drivers also to be on the same version. Fine. So the example, I have LabVIEW 2018 software installed in my system. You have to choose also NI Rio, the My Rio driver also of 2018 version. See, there is an option called download here. It comes around 16 GB. Okay, it comes around 16 GB. You can download. In case if you people are using LabVIEW 2019, okay, if you select this version, see, you'll get two options: download, and another one is install offline. Okay, select install offline. It will direct you to another page here. Okay, and you have to select this option and click download. Automatically your My Rio bundle software will be downloaded. Okay, so where you will get LabVIEW software, LabVIEW RT, LabVIEW FPGA, and the compilation toolkit which is required. All those things will be available in the bundle itself, and along with that you'll have My Rio toolkit also. That is very, very important. Okay, so My Rio toolkit, all those things will be available as a bundle. You can download and you can install it. It is not like 1 or 2 GB, it's around like 14 GB. Fine. So you can select the respective version and you can download the software. So drivers is not a trial actually. Yes, it is also a trial. It will come for only 7 days. But you log in, and if you try to create an account using National Instrument website, right? So you can extend it up to 45 days. Okay, you can make use of it up to 45 days. Yeah, thank you. And Dr. Suresh Kuri, I'm using LabVIEW 2018 version. All the drivers in my system is also having LabVIEW 18. So we, and Rio, for this My Rio hardware, NI has given support up to 2019 version only. It's for NI My Rio. Okay, when you're going for compact Rio, PXIs, and other Rio family based hardware, so we have support for all the versions. Okay, for only My Rio till 2019 we have the support. Okay. Any other queries, participants? If you have any queries, please let me know.
Which is a recent version available in market right now?
For which hardware, sir? Rio hardware, or generally asking, sir?
Both.
For Rio family hardware, up to 2021, they have released new version is already released. To get up to 2020, we have to check with the support for 2021. Only for MyRio, the last version is 2019, sir. So if you are going to use compact Rio, single port Rio, PXI based Rio family hardware, you'll get up to 2020. So only for MyRio, they have given the support up to 2019 version.
Thank you.
Yes, sir. Thank you, sir. For LabVIEW, Rio require whenever you want to develop a standalone system, obviously we have to rely on hardware. If I choose Rio hardware for developing an application, 100% Rio is required. Any other queries, participants? Means both software wants to install. Yes, sir. Yeah, software has to be installed so that you will get an option to simulate. Okay, only when you install the Rio driver in your systems, right? You will get an option to simulate the software. It is required. You have to install. Okay, thank you, sir. Welcome. Any other queries, participants? If you have any queries, please let me know. I'm ready to explain. Okay, if there is no query, sir, shall we have a break now? Because the second session starts from 12 o'clock, right, sir?
Yes, sir. I think we can take a short break, and 12
Yes.
o'clock we can start the
Yes,
session.
sir. Yeah. Thank you, sir. Thank you. Okay,
Yeah.
participants, we can have a short break.
Yes.
Torse sir,
Yes, sir. Yes.
I am getting error in this
Yes, yes,
feedback.
sir. Yes, sir. That was error from our end. Now I have corrected it, so it is accepting the responses.
Okay, sir. Thank you.
Yes. Okay. Thank you, sir.
Thank you.
Be there, I'll come.
Vishwesh, sir.